The problem of recognition of gaze is actual in the present time, and this problem is solved and is embodied in the device called an electronic nose. Basically, the electronic nose is employing multisensory arrays which generate vector multidimensional signals. The main advantage EN is universality. The electronic nose operates like a mammalian olfaction system. For instance, see the dog, which has one of the best natural olfaction. People employ the dog's nose since the middle of 19th century. So far, the dogs are most used experts to find drugs or explosive. You see how the trained dog is looking for drugs hidden in one of the bags. He goes confidently and it finds the target. But still, a dog is animal which might have bad or good mood, and his life as order expert is not so long. It is impossible to be absolutely sure of the results of his work. That's why dog cannot be a witness in a court. Moreover, dog's training is very expensive, and only 1 of 10 puppies passed courses to become a real bloodhound. The training course takes 5 to 25 months, and this is a fairly long period considering dogs' lifetime to be about 12-17 years. Regular contact with drugs during training and subsequent work makes dogs to be addicted that reduce their life.
Basically, the multi-sensor chip consists of substrate of oxidized silicon or aluminum, which is subdivided by 39 soplanar platinum electrodes. All the electrodes are covered with tin oxide nanowire matrix, so that the piece of matrix between two electrodes serves as a sensor. The sensor signals measured is a change of resistance and processed by linear discriminant algorithms or by artificial neural networks.
Here we show a hybrid artificial neural network which consists of coherent map and 3-layer perceptron. This is a network based on a number of various neurons. Let's get a close look at the sensor. Our magnification allows us to see inside the nanowire. The single sensor operates according to chemiresistive effect, which is a change of oxide semiconductor conductivity under exposure to gases. First, the oxide is covered with oxygen, which come from the gas phase, dissociate at the surface and capture free electrons from the oxide. Then, if reducing gases appeared, its molecules are absorbed at the oxide surface. Here the different routes are possible. The gas molecules may, as donor, inject electrons directly to the semiconductor. The second way might be a destruction of surface oxygen vacancies via so-called redox reaction. And third mechanism, which is most popular in literature, might be the reaction between the reducing gas and surface oxygen, which return localized electrons back to free state. In any case, all the roads lead to increase of electron concentration in the oxide semiconductor. We have to note that the efficiency of the mentioned processes depend on the geometry size of the sensor elements.
See how our electronic nose prototype operates. As an example of order, we use a cap from the dish with mint. We have 3 areas of gas recognition identified on the screen: air, acetone and mint mixtured with air. Following to the mint appearance, the multi-sensor signal processed by electronic nose algorithms goes from the zone of air to the zone of mint. So the device recognizes this gas appearance. As a second substance, we moisten paper with acetone. Now the multi-sensor signal goes to the acetone zone.
In the future, the electronic nose would find a wide range of applications in various spheres. In iPods, it can improve the accuracy to recognize drugs and explosives. In hospitals, it will help to diagnose various diseases. The doctor might take samples of exhaled air and pass it to electronic nose, which will show the concentration of various substances and differ the human's disease. In various industries, the electronic nose might be implemented in many production processes. For instance, it might serve to detect the leakage of dangerous substances and so to prevent its spread. Still, we may note what this device may be used not only for societal needs, but also for personal ones. It can be installed in kitchens and refrigerators in order to report house devices about degree of freshness of products.